they could only achieve a power level of about 300 watts. And that seemed to be a ceiling of functionality. And that was really my focus, to solve that fundamental power electronics problem.
Welcome to Avnet Silica's We Talk IoT. We'll chat with innovators, experts and business owners to learn how they are implementing IoT and using data to create new business opportunities. I am your host, Stephanie Ruth Heatle. Today, we explore how a Berlin startup, Heatle, transforms the simple act of heating liquids into a smart, connected experience. Traditional kettles heat more water than they need, they consume more energy, and they lack precision. Heatle offers a different approach. The company develops smart induction heating devices that heat the liquids directly in their containers. And this technology promises energy savings of up to 80%. What makes this even more interesting? The system learns user patterns. It integrates with smart home ecosystems, and the company also explores subscription-based business models around energy data. I am really happy to welcome David Riding, one of the founders of Heatle, to the show today. David, welcome. Tell us about yourself and about Heatle.
Hi, my name's David Riding. I'm the tech nerd within Heatle. I've been here from the beginning, over 5 years ago, and my background is obviously I'm English, so I like tea. Tea's in my DNA, and I'm an engineer. I'm 48. I've lived in Berlin now for 11 years, and got 2 children. And I love anything to do with creativity and making things. I've always been doing that since a kid, and I particularly like in this stage of my career to work on things that have some kind of importance or impact socially or through energy saving, climate issues. So all of these sectors I've worked in before. My previous background was in aerospace in the UK, working for large aerospace companies in defense. And then I've run my own company for 10 years in the UK that was about design and software. And I sold that company, had an exit, and that gave me some flexibility to move out to Berlin then. So now I'm here in Berlin, and I've worked for some companies here, including Next Big Thing, Boston Consulting Group, Singing Cat, lots of startups and also large companies. And so 5 years ago, I started this company just from an idea, from a prototype, and have basically worked with the team to take it from an idea to messy wires on the desk, right the way through to now a company. I'd say that we've transitioned away from a startup, and now we are in full production, delivering all across Europe, and I can talk about the details in those steps.
Wow, that sounds like quite the journey from aerospace to tea kettles. Why kettles?
Yeah, right. So as a kid, I've always looked at kettles growing up. They're very, common and popular in the UK and globally, actually. And I've always been fascinated with how they worked. I've been like that with all things, actually. I always like to know how things work. I take things to pieces as a kid. But I always notice with kettles that they are often overfilled, they get dirty inside of calc and calcium. And even as a kid, I was always switching off the kettle manually because there's a bimetallic strip inside the kettle which heats up with steam and it turns off the kettle automatically. So that's the same on every kettle, everything from the cheap ones for 15 euros right up to the more expensive for a few hundred. They basically rely on a bimetallic strip. And those things are very slow and lazy to turn off. So consequently, you get unwanted heating, like 30 seconds at 2 to 3 kilowatts. And years ago, I looked at this and did some basic maths on the back of an envelope and could tell that there was a huge problem because in every home and office globally, these kettles are not only being overfilled, but they stay on for too long. And the kettle was one of the most energy hungry devices in any home. So I always had this irritation at the back of my mind that I wanted to do something about
Okay.
kettles. And at this point in my career, I had the opportunity. So that's why we started Heatle.
Fascinating.
Yeah.
And what is it what do you do differently? What did you change
Yeah.
about the way a kettle heats water?
Yeah. Okay. So a kettle heats water via resistive heating. So technically, it's 100% efficient. Okay. It has mains AC applied to a resistive element that's made of nichrome wire. It's at the bottom of the kettle. And in an ideal scenario, that system could be 100% efficient. But in reality, as a product, a kettle is, like I said, overfilled. It stays on for too long. But also, the resistive heating element is quite far down in the kettle and not in contact with the water. It can't be because of safety reasons. So it's insulated. So those layers of insulation and the whole thing, the whole body of the kettle that needs to be heated up, that all adds to the inefficiencies. So what I wanted to do is heat the water in the cup, only what you need. And the most efficient form of heating is induction. So it works like a transformer. You have a primary and a secondary side in induction heating. The primary side is, in our case, in the Heatle, under the glass. So that's a 13-turn coil with an inductance of about 65 microhenries. And then the secondary side to this transformer is the disc. And the disc goes into the liquid and it gets hot through eddy currents being produced in the disc. And so the disc makes the secondary. It's like a 1-turn coil. So it's a huge step-down transformer from a high voltage on the primary side at 1,200 volts, right the way down to only about 3.5 volts, but a huge current in the circling around the disc in hundreds of amps. So that's how it works fundamentally. So behind that, you need an oscillator and safety and control and a user interface. So it was designed with the fundamentals in place in order for the customer side to heat any liquid in any cup. So it could be a bowl, could be a plastic or paper cup. It could
A plastic cup, even.
Yeah, even plastic cups. So, for example, the re-cups.
Yeah.
Many of our customers give us feedback and pictures on, I don't know, Instagram, and they're using their re-cup at home. So you can, reheating coffee and things. So it's very flexible, for baby milk and for soup and, all kinds of things. So I was always interested in this because it seemed to solve a few problems, saving energy, making a better user experience. So that's why my focus was on this. And and nobody else had done it before. There were some startups in the past that had a go at this in Germany and in France. And the more we worked on this, the more we discovered these things that weren't exactly public, and some were, some weren't. And we realized all of them failed for different reasons.
Okay.
They could only achieve a power level of about 300 watts. And that seemed to be a ceiling of functionality because of the way in which the system had to work. And that was really my focus, to solve that fundamental power electronics problem. And I did that. And then from that fundamental foundation of the electronics, the rest of the system was built, the user interface, the packaging, the plastic case. So it was designed from the inside outwards. Yeah.
Okay. And what challenges did you face? So you said you broke the power barrier that set you apart from the competition. What other challenges did you face?
Yeah, right. So the power barrier that seemed to be the ceiling was because most people, including myself in the beginning, tried to achieve the power electronics with, a half H-bridge driver circuit, which is very, very common. It involves 2 big transistors, MOSFETs normally, that drive a series or parallel resonant circuit. So that's fundamentally how it works. The problem is the secondary side of the coil, the disc that I mentioned, is variable. Okay, so it's inductance, its resistance, its characteristics change a lot because of the distance away from the primary coil. could be a thick base cup. The disc can be moving with bubbles. There are many factors that can affect how this works. So you need basically in any oscillator system, you need a feedback loop. And the problem with this half H-bridge topology that most people use is that the feedback loop was loose. It wasn't tight enough. So the transistors are hard switching. And we got a lot of help from some of our distributors and suppliers, including Avnet, who supplied our transistors, silicon carbide MOSFETs, actually. And what I did is I designed a custom topology that uses analog feedback. So there's no optocouplers involved. And with that, it was able to self-tune its resonant frequency on the fly very, very quickly, really in the nanosecond domain. So that allowed the driver circuit to not overheat, basically. So that was the fundamental part of the electronics. So yeah, so from that the system has to be controlled, and and from that become all of the software and the safety systems that really are also fundamental to the design.
Very cool. So most of the people, I assume, they already own kettles. How did you convince investors and customers that the world needs another heating device?
Yeah, right. That's definitely a challenge, because what we discovered is there are many marketing avenues you can take on a product like this. So there's just purely energy saving, which really appeals to perhaps the green market. And then there's the more kind of premium products that has features, functions, and benefits similar to an Apple product, perhaps. Yeah, and then there's like the kind of the geek nerd scientific aspect. So all of them have different characteristics. How does it look? How does it work? So really, during the market research, it was discovered that the market group is actually broad, and that actually makes the marketing quite challenging, because you can't pinpoint your marketing in one place and put all your power and money into that. It includes families, single people, students, mothers-to-be with baby milk and baby food, coffee market, tea market, because the device is so flexible. So what we did is we designed a product that looked nice and was easy to use, and that was the main target. And that's actually difficult to do, because it's very easy to put lots and lots of features into this, but to make it look sleek and simple and easy to use is more challenging than adding 50 buttons, So that was the challenge. Yeah.
Yeah, for our listeners who have not yet in parallel Googled, it looks basically like it doesn't look like a water kettle, which is nice, because I hate the water kettle in my kitchen, because I hate kitchen appliances, for example. I think I would be I would be the tech geek target group for you that also likes a nice design, right? Those water kettles are not pretty. They are just these ugly, bulky things that take up kitchen counter space. So how do I describe it?
It looks a bit like the Qi chargers for charging your phone, these discs with a power cable. It's a bigger one of those. So it's actually about 18 centimeters in diameter and about 6 centimeters tall, and weighs about 2 kilos. And it comes with 3 disc size options: small, medium, and large. So the small is good for the baby bottles. Medium is supplied as standard. That's 4.5 centimeters. It fits into most cups and glasses. And then there's a large disc, which is really for transferring more energy. There's more coupling between the primary and secondary. And that large disc is really good for large volumes of water, and particularly where the base of the cup or the teapot, tea canner, is really thick. Yeah, so the power drops off exponentially with distance. So the further the disc is away from the primary coil in the base of the Heatle, the lower the power. So in order to counter that, you can use a large disc if you like. So these are all optional accessories you can purchase if you want to. And actually, that's where the story started for Heatle, with the accessories. There's a whole range of accessories we have now and discoveries we made for other uses for the Heatle. So there's things like the hot water bottle, the Wärmflasche, tea filters, cleaning sets, holder discs for, where, the glass trays, for example, where you put your discs after use. a whole range of things, which really came from the customer community. So we reached out to them, we gave them polls and questions, and we listened to our customers. They had suggestions, so they could vote on ideas. They could also, as an option C, for example, they can propose their own ideas. So we took those things and we developed products in collaboration with our customers, a huge step in development for the product with improvements and particularly around the user interface. So we're going to be using NFC tags, for example. So working with Avnet, they supplied us with NFC solutions around ST Micro, actually. So they make a whole range of NFC tag readers and writers. They were actually incorporating an NFC read-write into the new Heatle. Now that's NFC is nothing new. It stands for near field communication. The tag is passive and it's energized by the transceiver that's reading this thing, and that's just over. I think it's 13.8 meg frequency, and there's a tuned circuit inside the tag. So these things are used in products and in your phone and in payment cards and business cards. It energizes that and sends a small amount of data. So what we want to do is we want to set the Heatle parameters automatically, because currently the customers are choosing the power, time, and temperature manually, right? So using this knop on the front, they can rotate. There's an LED display, and they can choose high power mode, low power mode. They can choose, profiles like baby mode, for example, for baby milk, and they can do all kinds of things. But some of the feedback we got from customers is it's fiddly, and it's a lot of menus and sub menus. You can set the temperature steps in 1 degree, 5 degree, or 10 degrees. You can do that in settings. So all of those things we want to make easier for our customers. So when it comes to settings, we're going to use our app, our mobile app, and we'll have a page where you can do all your settings on there with a nice GUI, graphical user interface. But when it comes to actually setting the power, time, and temperature, then we're going to do that with NFC tags. So we have a range of teas already, custom teas, very premium, but tea is something that should be heated to the correct temperature. We have these presets. So how about putting an NFC tag on our tea bags? We have these big tea sacks that we sell.
Oh, okay. So the NFC tag is on the bag, and then you put the
bag.
tea.
Exactly.
Oh, okay.
So it's on the product. And that thing is really simple to use. You just hold the tea bag near to the Heatle in the correct location. It's just to the left side. And it will read and set the power, time, and temperature. Okay. So
smart tea.
Yeah, right. And it's just simple, really. Of course, the customer can do it manually, but we've made the process simple and easy. And it's the same for our accessory, the Wärmflasche, the hot water bottle.
Yeah.
That should be heated to 80 degrees. And, we supply this hot water bottle, which has temperature feedback built into it. We supply it with special liquid inside. So the customer doesn't need to pour it themselves and risk burning or overfilling or using 100 degrees. All of those things shouldn't be done. So again, that's a brand new creation. And it's a premium silicone hot water bag that we, manufactured ourselves with a lovely, cover. It's a special wool cover. It's very soft. And again, you need to set these 3 parameters manually: the power, time, and temperature. So we're also putting the tag around the neck of the hot water bottle, an NFC tag. So again, you put your hot water bottle on there when you want some, to heat it up, and it will automatically set these parameters, like 80 degrees, for example. So that's something that
clever.
We're bringing in, and it's like I say, it's not a particularly new technology; it's just a new use. So that's really a lot of what we're doing. We're taking a very old fundamental technology like induction heating and adding a new digital layer. We're abstracting that such that the customers find it easier to use.
It is incredible how many use cases you found around such a simple technology as just heating liquid or heating liquids.
Right,
That's
right.
really,
It's
that's
just the
really
beginning,
incredible.
actually, because there's the whole coffee industry. So, the mocha pot, for example, this is the 2-stage metal pot. It was originally invented
Yes.
in, I think it was the 50s by Bialetti. You may have one.
I have. Yeah, I use one of these for my espresso. Yeah.
Yeah, right. And it's very common. It's, it's if you look at the Bialetti coffee pot on Amazon, It's got, almost 5-star reviews from many thousands of customers. So it's still very popular, but it has its drawbacks. Just like the hot water bottle, it's something that gets heated, but there's no temperature feedback. We're actually working on a really cool product. It's in its latest development phase now. We're going to get it manufactured soon. It's a mocha pot with temperature feedback, so it automatically turns off. So that avoids, again, overheating. You can overheat the coffee.
The coffee gets bitter if you make it too hot, right?
It really does, yeah.
And then it burns the whole thing. Yeah.
It does. It burns, and particularly on a gas or electric or induction cooktop, it's very easy to perhaps walk away whilst that thing's heating, because it takes like 5 minutes to heat.
Yeah.
And then it goes crazy with the vapor pressure. So water expands to 6,000 times its volume when it's in a gaseous state. So there's a huge amount of pressure down there, and it pushes up and it goes through the coffee into the top chamber, but there's no feedback. So our product has simply got a temperature sensor in the top chamber, and when the water touches it, the Heatle recognizes the rise in temperature and it shuts off the base. It's really as simple as that. But just that innovation has made the product completely usable. So you can just put it on the Heatle, and again, an NFC tag can be on this. So it just does it automatically. It's very quick and easy. So that's really the definition, I think, of the Heatle, to make your life easier in the kitchen. It's one device that does many things. It's easy to use. It saves energy, saves money. So yeah,
you don't need to clean it.
That's right. Yeah. Well, actually,
like
you don't have to clean the base so much. The water cooker, the kettle, does get completely filled for the calcium. I hate it. But the discs also, our metal discs, they do also get calcified. And also, if you heat milk and hot chocolate, it does need to be cleaned. So the cleaning feedback from our customers, actually, we found the cleaning is actually quite challenging. We developed a cleaning kit like you would get for your coffee machine or your dishwasher. And
you thought about everything.
Yeah, we had to. That was actually quite crucial, because the discs really do get, not dirty, but like calcified over time. But it depends on the hardness of the water in your area. In Berlin, it's particularly hard. So we have a cleaning set. It's completely bio, organic, and that thing is basically made of, the liquid's made of concentrated lemon juice. And it works really well. We have a cleaning mode, an NFC tag, and it cleans the things really well. They come out like new in about 30 seconds. Yeah, that's one of the things in the ecosystem that we've worked on.
Very nice.
Yeah.
And are you thinking also about broader smart home integration use cases?
Yeah, definitely. Yeah, we do want to integrate to the general smart home topology. Like Matter is now very popular. Most people in their homes have some kind of smart device like Alexa or Google. So we would connect to this, and we are working on this, but we're not going to connect in the way some smart devices connect to your home. I mean, we don't see the need to start the Heatle automatically using a voice command. This unnecessary smart layer. I mean, there's no point for that. But where it could be useful is integration with our app. So if you want to use the app with the Heatle for software updates or looking at the analytics, you don't have to be right next to the Heatle. You could be on the Wi-Fi in your house. That connects to the Heatle. And if you want to look at your energy savings on the energy savings tab of the app, you can look at, how much energy you've used in kilowatt hours. And you can even see comparisons of how much energy you've saved to a typical kettle.
You mentioned data and analytics now quite a bit. And I think in our briefing call, you mentioned that you're now also starting to make use of the data that you're collecting from your customers. Can you elaborate on that?
Yeah, sure. And the first thing to say fundamentally is data privacy is very important. So for any customers that want to opt in.
You are a German company, I can tell you.
GDPR is fundamental. So so any customer that does want to opt into this can share their data. And so we can, in our platform, and even including the customers with their login, can actually look at, like I say, the energy usage. So inside the Heatle, we measure the voltage and the current. And we also measure the phase shift between the two, power factor. And the Heatle is designed for a very good power factor, almost 1. And I achieved that with the type of drive electronics I use. As part of my DC link, I use a very small DC link capacitor. So that doesn't create too much of an offset between the voltage and current, which is really important. So you use all of the energy that you're getting as less reactive power. So you're using the real power, and that's fundamental. So you can look at these factors from the data that comes in. So if any customers are having challenges or issues, or if there's a warranty case, if they've perhaps broken the glass, or if there's any issues, we can ask for their permission. They can check a box in the app. We get the last 20 seconds of usage, and we can look at, hey, you know, what's the current when it's scanning, when it's looking for a disk? What's the power when it's running? And we can do some basic analytics. And if there's a need to, have a warranty case, then we handle all of the warranty cases ourselves, and we have an efficient system, and we can, change a glass, for example, and send it back to the customer within a few days.
And so you use it for support and warranty use cases primarily, or are there other?
Yeah, sure. So yeah, like on your phone, you can have software updates. And again, for any customer that would like this, they can have a software update. Inside the Heatle, we have a main processor chip. It's actually a PSOC 5LP, which is a really nice microcontroller. It's not the newest thing, but it's very reliable. And it has these digital building blocks inside. So this is logic that can run without software. So we can use that in a safety layer, for monitoring things with comparators and op amps. We can monitor current and temperature and things. And also, fundamentally, there is Bluetooth inside there. So we use a Bluetooth module, and that's NRF52832. It's a module that's supplied to us, and that allows a connection to, like, the phone, for example. Yeah. So the app can connect to this, and we can update both of those devices inside the Heatle securely, encrypted updates. So to update the Bluetooth chip, and also the target microcontroller can also be updated via the Bluetooth. So if we want to roll out any new features or functions, such as the hot water bottle, the coffee pot, all of these things, even a request from customers was to adjust the temperature in finer steps. The original software adjusted temperature in 10-degree steps. And we thought, that's all customers would need. But actually we were wrong. So we changed that, and lots of the customers, and we can see how many, for those that have opted in, have updated the software. And then it gives the 1-degree step if you want that. And that can be useful for some people. Personally, for me, my Heatle adjusts in 5-degree steps. So that's good. Yeah.
What other user patterns have surprised you most?
So some of the new accessories that were brought in were around consumables, tea, Glühwein at Christmas. These things really surprised us.
Mulled wine. In
this
English,
mulled
right?
wine, that's right. And again with mulled wine, there's this need to not overheat it. You don't want it too cold. So there's this same like power, time, and temperature need. And so this was introduced, and we were really surprised how popular that was. So these consumables, and also the liquid for cleaning. So those are things we didn't expect, but came later, and there's this interest. Yeah.
It's really cool how your product evolves also around the experience the users make, and then
absolutely
feedback that to you. That is really cool.
That's right. Yeah. So we are trying to better communicate in this way. And, in our startup phase, we tried our best, but now we are really improving with this. So even with regular tech videos, short 30-second videos, that just show things like, whilst the Heatle's heating, you can rotate this knob on the front and you can see other things, metrics, like the power and the target temperature and the live temperature from the rod. So we actually measure the temperature inside this rod that goes into the cup. We measure the temperature there, and there's a small digital temperature sensor there that's connected on I2C up to the microcontroller at the top, small antenna and LED that shines up through a window. And the rod is another interesting part of the Heatle. I think it's one of the key parts, actually. This rod is magnetic, and it connects automatically. Like, it connects to these discs that also have a magnet inside. And that was a challenge to design, but a challenge that we had to overcome, because we wanted to measure the temperature in the cup or in the product, like the hot water bottle. And what we started with was batteries, small batteries inside the rod, and tried all kinds of things, alkaline replaceable batteries, lithium polymer batteries that could last a long time but could be recharged. Supercapacitors were put in some of the early prototypes. But that created problems because if you need to ship your product, globally, as we are starting to do, you have to take care of battery safety management, safeties, all the safety regulations regarding that. Even with production, if production is overseas, it's not easy to ship lithium, large quantities as well of lithium cells. So I designed it to work without batteries. So it uses energy harvesting. So inside this small rod, which is 6 millimeters diameter, stainless steel, non-ferromagnetic, so it's the 300 grade, it has a receiver coil at the bottom that was custom designed. And the energy field from the base, a torus shape, like a donut, it picks up energy from the base and it charges. It's a bit like Qi charging, actually, and a bit like the NFC tags that harvest energy. We take the energy from the base. The resonant frequency down there is around 24 to 28 kilohertz, and it goes through a small rectification circuit inside and a bank of normal MLCC, that's ceramic capacitors. A bank of those holds enough charge to power the radio and the temperature measurement only whilst it's heating. That's actually, we realize that's only when you need it. You don't need the rod to be on 24 hours a day.
Sure.
So whilst it's heating, the rod powers up, and then it starts reporting its temperature down to the base, and that works. So that was pretty cool to have that working. So it makes a nice slender rod. As I said, 6 millimeters diameter. The wall thickness gives us an inside diameter of 5.4 millimeters. So the PCB inside at 5 millimeters slides in and fits perfectly, and it allows us to work without batteries, and it just looks a lot better. Yeah.
I can imagine that for enterprise or commercial users, it would be also interesting to integrate the Heatle into like a kitchen countertop.
Yeah, right. Yeah.
So that you can have like a...
Definitely. Yeah, that's a good point. Yeah, thanks for the prompt. Yeah, that's actually something we're working on. So again, we listened to customers and they said almost exactly the same as you. Would be nice if it was integrated in. So we have done that. And basically, the Heatle case, the Heatle, the way it looks, we can take off the outer skin of the Heatle. We can replace it with, like a metal frame that has tabs with holes so it can screw up underneath a countertop. It can work through the induction field, the electromagnetic field can go through any non-ferromagnetic material, glass, ceramic, wood, polymers, it can work through those. That's what we started to do. And we have some demo units. Also works great in sinks, in actually the sink, because this is, again, was feedback from our customers. Can we fit it into a sink? Why? How? We made some prototypes.
Because that's where the water goes automatically.
Yeah, it's exactly the right place to have the Heatle, actually, because, you need to fill up with water. You need to perhaps empty a cup. You need to rinse the disc after use. You're right next to the tap. So why not? So, so it, in collaboration with a large kitchen sink manufacturer, we've developed a range of prototypes which work really, really well. And the fact that we've got Bluetooth in the Heatle with this Nordic NRF chip, we can have a remote control. So this remote control that can control the Heatle to start the scanning, set the power time temperature, or the NFC tag can be on the counter surface or near to the sink. So this little remote control we've got, and the prototype's only a 3D printed thing. Again, it's got a little Nordic chip in there, is magnetic, and it can go anywhere in the kitchen. You can even clip it up underneath the worktop cupboards, and it can be different colors. You can have wood, metal, plastic, red, green, whatever. So it matches your kitchen. There's different fascias that go onto it. That has to be battery powered. But the cool thing is, in our prototype, we have a coil in there, a receiver coil, and you hold it next to the Heatle, you click charge, and it will charge that thing, and it will last for months because it drops into a low power mode. We wake up the Bluetooth chip in the remote control with an interrupt, so it can go into a deep sleep. With a button press, it wakes up. So yeah, that's another use case that's coming soon, and that's really more of a business to business type things. One of our investors is actually in the kitchen industry, in large scale distribution. and has a huge platform that the kitchen manufacturers and distributors use. So we already have, a good soft entry into that market, and that's something we're really looking forward to.
It's incredible. Yeah, I think I would not have expected that an episode about water kettles would fly by so fast, but I think we are almost at the end of the show. It is really incredible to learn that when you listen to your customers, create a great user experience, how many use cases and how many new ideas can come up and make a terrific product. It sounds really exciting. The only thing I have left to ask you is the most difficult question of the show. If you had to put together a soundtrack for this episode or your company, what song would you put on it?
Oh, wow. Do you mean from the technical side or the business side?
What is your soundtrack when you wake up and go to work?
Oh, right. Okay.
Kind
Wow.
of. What is the song that puts a skip in your step and it's like, Heatle, let's go?
Well, personally, I like James Lavelle, the artist, and the particular track is called Sweater Weather, the remix by James Lavelle. I listen to that most mornings coming into work. It was a soundtrack really to the development side.
Nice.
But also, as a cliche, it could be any song to do with getting hot, So there's so many song titles about things getting hot in here.
Sure.
Yeah, or or something by the blues bands, Canned Heat, or something to do with.
I was also thinking about the heat is on.
Exactly. Yeah, something like, or it's getting hot in here. These kinds. Yeah, so
Very
that
nice.
would be a good cliche.
I will put it on the playlist.
Good. I look forward.
Yeah, we have a playlist on YouTube and on Spotify
Cool.
where we collect all the contributions from our guests.
Nice.
So thank you, David. It has been terrific. The time flew by so fast. Thank you for being on the show. It was really insightful, and thank you for sharing all your expertise.
Thanks for inviting me. Thanks for making the time to listen, and much appreciated.
Great. So thank you for listening to We Talk IoT. Stay curious and keep innovating.